So, welcome to next lecture on two port networks, and we have already seen that if any given two port network like this will have I can describe this network in terms of input port voltage currents and output port voltage current, and this is how the convention is followed. This is the convention for Z, Y and H parameters. We will always assume that both the port currents are going into the network, and based on that we have found out these things, that is in case of Z parameters voltages are on the left hand side, and it was like this I 1 plus Z 1 to Y 2, and this is equal to Z 2 1 I 1 plus Z 2 2 I 2. This is one thing, and this I 1 and I 2 can be also represented as Y 1 1 V 1 plus Y 1 2 V 2, and this is equal to Y 2 1 V 1 plus Y 2 2 V 2. These two equations are one and the same, but only thing remember that Y 1 1 is not 1 over Z 1 1, that we have discussed. So, this is about Z and Y parameters, and we have also discussed about H parameters, and it is represented as V 1 and I 2. V 1 is represented as I 1 V 2. So, this is H 1 I 1 plus H 1 2 V 2, and this is equal to H 2 1 I 1 plus H 2 2 V 2. So, these three, and similarly here this I 1 V 2 can be expressed as G parameters like this. There is another, that is and I 1 V 2 can be expressed as G 1 1 V 1 plus G 1 2 I 2 and G 2 1 V 1 plus G 2 2 I 2. If inverse exists, G will also exist of this H matrix. Similarly for Z and Y matrix. Then in my last class I told you that there is another parameters called ABCD parameters, and here it is written like this, that this given network, but only thing is here what we will do is this, this is voltage of port 1 with this polarity, it remains same as it is, and here it is voltage of the other port, that polarity also remains same, but only thing for I 2 we will indicate it is coming out, because of the nature of transmission line. Okay, I would like to written I 2, this is how will be written. And in this case what is done is this, you can write this as current entering, but then you should write minus I 2. So, I will draw exactly what it means I 2, and then the input voltage and input currents can be related with output voltage and output current as a V 2 plus B I 2 and I 1 is equal to C V 2 plus D I 2. This is how, and we have seen how A and B can be determined in my last class. Only thing is it is 1 over A, first calculate then calculate A. because there will be some problem. You cannot excite a network with a voltage and still claim the current in this is 0, very difficult to achieve that. Okay, so, this is the thing. Now, after learning, and therefore, I will be able to relate ABCD with Z, Y, H, whatever I like. We are not going to discuss. Today, first I will tell you one important property, because it is a linear and bilateral networks, and if it is so, then we know that theory of reciprocity will be always true. Theory of reciprocity. You recall that theory of reciprocity tells us that if in a circuit, if the circuit is reciprocal, then if you apply across this port some voltage V 1, and if you short the other terminals and the currents are like this I 2, I 1, you do one case like this, apply voltage, output terminal shorted, and you also do these things, that is, you apply a voltage here V 2 and this is I 2 and short circuit this is I 1. Then theory, if this network is reciprocal, then the ratio of this voltage and current and this voltage and current will be same. If reciprocal, we have discussed it earlier, reciprocal, if reciprocal, then we know that V 1 by I 2, this ratio should be equal to V 2 by I 1. It is always true. While describing intelligence theorem, from that we establish this. Therefore, this ratio will be same for a reciprocal network, which demands that the network element should be linear like RLC, and also they should be bilateral. RLC are all bilateral things, no diode present like that. So, if this is V 2, then this will be I 1, and you see this V 1 by I 2, the sense of the current I 1 is also same, flowing this way. So, this is the thing should be verified. We will now try to look at the situation that if a two-port network is reciprocal, then will there be some what is the condition that the two-port network, if it is reciprocal, we can see, then this must happen. That is what we are going to study. For example, that is I will write it like this: to find out parameters if a two-port network is reciprocal. I will better write to find out conditions, when a two-port network is reciprocal. That way it is better to express. So, let us take with respect to Z parameter. Suppose this is a network this is your V 1 and this is your, first I draw the raw 2 port network. This is how it is in general, these are the things. And so, what I have to do, and these are the equations, V 1 is equal to Z 1 1 I 1 plus Z 1 2 I 2, and V 2 is equal to Z 2 1 I 1 plus Z 2 2 into I 2. These are two things. Now, to find out if this network is to be reciprocal, then V 1 by I 2 with secondary shorted, I mean other port shorted, will be same as the ratio of V 2 by I 1 when the input port is shorted. So, we have to find out these two and equate them, from that the condition will emerge. So, what is this? So, first therefore, V 1, what I have to do is this is the general network. Now, if this network is to be reciprocal, we know that what you do, you find out, you excite the input port with a voltage V 1 and short circuit the output port and record this current I 2 and this is I 1. And what we have to find out is find V 1 by I 2. I will find it and keep it. So, how to find out that? It is to be found out using these general expressions, but under this condition of this experiment, V 2 is 0, V 2 is 0. So, from the first equation you see V 1 is equal to Z 1 1 I 1 plus Z 1 2 I 2. I want to find out, here no V 2 exists, therefore, I 1 I 2 and V 1 all are present here. So, from this I can say that V 1 by I 2, V 1 by I 2 is equal to Z 1 1 by I 1 by I 2, that is divide both sides by I 2 and plus Z 1 2, is not. This is the first equation will give you. Now, but I would expect that on the right hand side only impedances are present, why I 1 I 2. So, the second equation will give you that ratio of I 1 by I 2 as, because V 2 is 0 under this condition of this experiment, and this is nothing but Z 2 1 I 1 plus of Z 2 2 into I 2. Therefore, from this I can say that I 1 by I 2 will be equal to minus Z 2 1 by Z 2 2, is not. I 1, oh sorry, it will be different, correct me. So, I 1 by I 2 I will do. So, Z 2 2 by minus, because I 1 by, so this is the thing, is not, this is correct. Therefore, from the first equation then I get V 1 by I 2 to be equal to this I 1 by I 2 ratio, you put it here, it will become minus Z 1 1 Z 2 2 by Z 2 1 plus of Z 1 2. So, this is the thing. So, V 1 by I 2 I have found out like this. Then I have to go to other situation, that is, in this case if we claim this network is reciprocal, what I am going to do is I will excite this with a voltage V 2, this current is I 2, and this port I will short it, and this current is I 1. And what I have to do now? Find under this condition V 2 by I 1, V 2 by I 1, this ratio to be found out, and then eventually I will equate this with this for the network to be reciprocal. Now, how to do it? Okay, these are the basic equations. Once again I go to those equations and say that V 2 by I 1 is to be found out. So, from the second equation V 2 is equal to Z 2 1 I 1 plus Z 2 2 into I 2, is not from this equation. Therefore, V 2 by I 1 will be equal to Z 2 1 plus Z 2 2 into I 2 by I 1. Then who will give me this ratio I 2 by I 1? From the first equation, V 1 is equal to 0. Therefore, from the first equation I will get 0 is equal to, that is this equation, 0 is equal to Z 1 1 I 1 plus Z 1 2 I 2, we will get that, and from this I will get I 2 by I 1 is equal to minus Z 1 1 by Z 1 2. This is the thing I will get. Therefore, I will put this here to get this V 2 by I 1. Therefore, V 2 by I 1 will be equal to Z 2 1. This minus will come. So, minus Z 1 1 Z 2 2 divided by Z 1 2. This is the thing I will get. Now, if this network is not reciprocal, then these two values would have been different. This is the way it is, this is the way. Therefore, if this two port network is reciprocal, then I will demand that this blue V 1 by I 2 should be equal to this red V 2 by I 1. Therefore, the condition is very easy to understand. So, I will say that it should be then equating V 1 by I 2 is equal to V 2 by I 1. It will give you minus Z 1 1 Z 2 2 divided by Z 2 1 and plus of Z 1 2, that is this quantity should be equal to this quantity, that is equal to Z 2 1 plus minus Z 1 1 Z 2 2 by Z 1 2 Z 1 2. It will be like this, is it? Therefore, from this we can conclude that these two will be true if Z 1 2 is equal to Z 2 1. From this it can be told, na? Or you can just multiply this because the numerator or that is Z 1 2 Z 2 1 minus Z 1 1 Z 2 2 divided by Z 1 2 etc. And this side it is also Z 1 2 Z 2 1 minus Z 1 1 Z 2 2 by Z 1 2. These two will numerator same. So, this is true. So, for reciprocal two port network, reciprocal two port network Z 1 2 must be equal to Z 2 1. Therefore, that is these elements will be same, these two elements should be same if the network is to be reciprocal. Therefore, if you have found out given the Z matrix of a network, if these two elements are equal, then you can be rest assured that it is a reciprocal to port network. Now, similar conditions let us find out for Y matrix. Very quickly we will be able to proceed now. So, reciprocity condition for a two port network to be reciprocal. In terms of Y matrix, in terms of Y admittance, short circuit admittance parameter matrix in terms of Y. So, once again same thing. In case of first I write down these two basic equation, one is I 1 is equal to, quickly let me do it, plus y 1 2 V 2 and I 2 is equal to y 2 1 V 1 plus y 2 2 V 2. This is the general thing, and I have to find out under these two conditions. I have to find out the things. I will excite in one case this, suppose input port, I will excite it with same thing V 1 and short circuit this one like this, and find V same, exactly same way. I have to find out V 1 by I 2, no matter whether you are representing network at Z parameters or Y parameters. I will simply say this V 1 by I 2 should be same as this V 2 by I 1, that will come here. So, find this and you short the secondary V 2 equal to 0. Therefore, these two fundamental equations give you that I 1 is equal to y 1 1 V 1, is not, I 1 is equal to y 1 1 V 1 and V 2 is equal to 0. This is one equation, and from the second equation you will get I 2 is equal to y 2 1 V 1 y 2 1 V 1, but V 2 is equal to 0. Is it? Absolutely okay. Therefore, it is I have to calculate V 1 by I 2. Therefore, this equation will not be used here, because this equation straight away give you V 1 by I 2 is equal to y 2 1, and we keep this result. V 1 by I 2 is 1 over, it will be 1 over y by 2 1, correct. It is admittance, no? 1 over y 2 1, we leave it there. Then the same thing I have to do is this, I have to excite this network, same network, I will excite from this side with a voltage V 2, and this will be I 2, and this I will keep it shorted and would like to find out this ratio. So, my goal is to find V 2 by I 1, that is what I have to do. So, to find that we come back to the fundamental equations here and write down those two equations under this condition, that is V 1 is equal to 0. So, the first equation will give you I 1 is equal to y 1 2 into V 2, because V 1 is 0. is not, and no point in writing down the second equation, because I have achieved what I wanted to find out from the first equation itself, that is V 2 by I 1 is equal to 1 over 1 y 1 2. Therefore, I conclude that these two are to be same, these two should be same if reciprocal. Which means that 1 over y 1 2 is equal to 1 over y 2 1, or I will say y 1 2 is equal to y 2 1. This is the condition, that is off diagonal elements should be equal. So, this and this, these two values should be equal if it is to be reciprocal. So, once again looking at the admittance matrix, I will be in a position to conclude y 1 2 is equal to y 2 1. Now, after doing this, we will then find out what will be the condition for the h parameters. Let us see that. So, condition for reciprocity, condition for reciprocity in terms of h parameters, in terms of h parameters. So, once again we will be do the same thing, but let us write down. So, it was V 1 I 2 general equation is this, and it is expressed as H 1 1 I 1 plus H 1 2 V 2 and H 2 1 I 1 plus H 2 2 V 2. Once again, I will be just a rule for verifying the reciprocity is remains same, why it should differ. It does not matter whether you are expressing a two port network in terms of H, Y or Z or in terms of ABCD. That condition is to be satisfied. So, once again you see, you apply a voltage V 1 and keep this shorted and note down this current and this current like this, and to prove reciprocity theorem I need this value V 1 by I 2, find. So, how can I find that V 1 by I 2? So, put this condition, that is V 2 equal to 0. If you put, you find the first equation will give you V 1 H 1 1 into I 1 plus 0 into H 1 2. So, there it ends, and second equation will give you I 2, I am sorry, this is V 1 only, there is no V 1 1. So, V 1 is equal to H 1 1 I 1 B 2 0, and second equation will give you I 2 is equal to H 2 1 I 1 and B 2 is 0, that is it. But my goal is to find out V 1 by I 2. So, just divide these two equations and you will get that V 1 by I 2 is equal to H 1 1 by H 2 1. So, we keep it this result. This should be equated with the reverse process, that is in the second case what you have to do is this, you have to excite this side with a suppose voltage source plus minus, you excite V 2, this current is I 2 and the other side you keep shorted. So, that I 1 is there, but V 1 equal to 0. So, once again go back to these fundamental equations and say that with V 1 equal to 0, the first equation will give you 0 is equal to H 1 1 I 1 plus H 1 2 V 2, is not. And what you want to find out? Find V 2 by I 1, this ratio I have to find out. Write down the first equation, V 1 is 0, shorted H 1 1 I 1 plus H 1 2 V 2. And I have got the result, because V 2 and I 1 this ratio I can find out. Therefore, V 2 from this itself, second equation need not be written, V 2 by I 1 will be equal to minus of H 1 1 by H 1 2, this will be the thing. So, this is the other thing. For this, this two port network will be reciprocal, provided these two are equal, these two must be equal, which means that condition is H 1 1 by H 2 1 is equal to minus H 1 1 by H 1 2. Or I will say H 1 2 is equal to minus H 2 1. This is the condition. See, for a given two port network, if it is reciprocal and if you want to represent it in terms of Z parameters, then the condition was Z 1 2 is equal to Z 2 1. If the same two port network, if you represent it in terms of admittance parameters, then also Y 1 2 is equal to Y 2 1. And if you represent the same networks in terms of H parameters, then the condition is this. There is a slight difference, a negative sign will appear for Z parameter, this is for Y parameter representation, this is for Z, Y and H parameters. Therefore, looking at the parameter values, you to establish whether it is reciprocal or not, look at the diagonal elements here, that is this element and this element. If it is 2 and if this is minus 2, then this must be reciprocal. Okay. So, this is the condition for reciprocity in for these three matrices Z, Y and H parameter matrices. Naturally, question comes, so what will be the condition for reciprocity if the network is represented in terms of ABCD parameters, and that we are going to do in the next class. Thank you.